Okay, welcome everyone. It's 6 people in the room. It's I think good enough for the start. It's our first time at the Group Gaming Memory Computing Conference. It's first time for Starcounter. So let me just introduce myself and the company. I guess that none of you have heard about Starcounter before. So Starcounter is a Swedish-based company, and it has been founded more than 10 years ago by a serial entrepreneur called Gekås, and I want to tell you his story, because the reason why he created this in-memory technology and started the company is because for many years before Starcounter, he has been involved into building enterprise systems for the largest Nordic enterprises. And in Sweden, you cannot buy strong alcohol in department stores. You have to go to a special place. It's called Systembolaget. It's a system magazine, system store. You have to go there, show your passport, and you get alcohol there. So it's a really huge store, and it works in all Sweden. There are hundreds of stores. So he built a system for that department store chain, retail system, based on available technologies, and he has done this in the 90s. He also built a retail system for one of the largest Nordics bookstore, Academy Bookhandel. So he has quite a broad experience in building retail systems and other kinds of systems for the largest Nordic enterprises. And over this process of building, he came to realize that there is a problem with how people build those systems. And his point was to alleviate and remove these problems. And he realized that he can only do this by building a new kind of system. And that's what he started to do in the early 2000s. So currently Starcounter is quite a big company. We grew up to 40 employees in 3 years. And we are expanding not only in Nordics, but in Europe and in the US. So Starcounter is in-memory application platform. And today, this is not something new. You heard about these things from SAP, from Group Game, but it was quite a new thing when we started out. And it's a platform because it's not just a database that you use to build your enterprise system, but that's also the application server that you write your business logic with. There is a web server, there is an application development framework, there is a client-side framework, and all that combined allows you to build efficient and simple solutions. By simple, I mean they are simple in development standpoint. It means that you spend less time building system of required capacity and functionality. So Starcounter is a combined application server and a database. It's very high performant. It has a broad number of installations across the world. We have 1,000 installations worldwide, and these installations are used by tens of thousands of end users, actually hundreds of thousands, or maybe even millions. I actually didn't count, but these are systems built by independent software vendors. So currently we are going to approach North American market, but we are already established quite a nice presence in Nordics. So just before we move on, some words about myself. I've been involved in software development since the age of 5, and I've been doing all kinds of things, not only just software development, but actually artificial intelligence, natural language processing, high-performance computing. I was in roles of university lecturer, software developer, CTO, evangelist, and I've been in different circumstances. And I think that you have to really be fresh, hands-on developer if you want to lead a company that's doing rocket science. So that's what I'm at today, and I'm trying to be a fresh developer. My main language is C++. I'm a low-level developer. Nevertheless, I'm in the role of CTO, and I'm helping the company to move forward in the in-memory business. So I'm going to tell you some stories about our customer cases, and these stories are very interesting. They are quite contrary to what you used to hear about building enterprise systems. And this process is typically complex. It lasts for many years. It overcomes the budgets, and so on and so forth. And you don't want that. So the way how Starcounter helps enterprises build their software is different. That's my first example. This is one of our first customers. They're our customers since 2011. So Gekås is a big retail store in Sweden. This is a huge retail store. Just to give you an example, this is annual turnover of the company, in fact, 2 billion SEK annual turnover. Just to give you a comparison, there is a big department chain in Sweden. It's called OLAP. They have 100 stores across Sweden, so it's a big chain. And their annual revenue is about 6 billion Swedish crowns. So one store in annual turnover is worth the full department store chain. So this is kind of significant place to be. And they had their previous systems built with Microsoft stack, and they failed to scale because they really had to scale this business. They have thousands of people coming every day to the store. So that was a problem for them, and they turned into Starcounter. And by turning to Starcounter, they managed to reduce the total cost of ownership times 100. They moved from their legacy cluster of database instances and application servers into one server that runs main Starcounter database, one failover machine, plus a cluster of point of sales, which should be operational in case you lose the connection. So apparently, the main server, the main business, the warehouse management system, tracking sales, forecasting, stock, and so on and so forth, this runs on a single machine. And this machine sustains a pressure of at least hundreds of heavy operations a second, and at the peak times it can be thousands of operations per second. This is pretty significant for retail business. And this is not the largest capacity of Starcounter. I will show you this in different examples, but for retail it's quite significant. So that's how they done. And currently they still run this system. The number of people coming to the store continues to increase, but it's still a single Starcounter machine. And this is how it looks like from the architectural perspective. You have a traditional UPC that is consistent of several machines or cluster of machines that runs your daily business. And by moving to Starcounter, we switch the main server to run on a single machine. And also you add offline point of sales. These point of sales are synchronized to the main machine by asynchronous master-master replication mechanism. So in that sense, Starcounter really is the technology that allows you to build a distributed system. Even though, unlike grid gain technology, we don't put distribution and scale out in the main corner, right? Because we know that for large amount of our customers, all the things that need to do, they can do on a single machine. Nevertheless, in many cases, you have to do distribution. You have to do failover, you have to do geo-distributed scenarios, you have to do high availability, point of sales, all those things Starcounter is capable of. So now I want to turn to the next example. This is an example of an ad tech company. It's called ADFENIX. It's a startup. They started about 3 years ago. And they try to build a system which sells ads on real estate websites. So the website sells the ad, and the system that they build has to target the ad to a relevant user on Facebook. And they tried to build this with different approaches. They tried RabbitDB, they tried SQL Server, and they didn't really manage to get there. It was either too complex or too expensive, or both. And they turned into Starcounter, and they started out pretty simply, actually. It was one developer building this system over summer, and I helped him run this system in the basement of Starcounter. So in 3 years, they are an international company with hundreds of customers worldwide. And they run this list of customers on 5 commodity servers in Hetzner. And these servers are not actually fully loaded. When they run this system on the servers, actually we see that the CPU is maybe 20–25% loaded, so there's still big capacity on the back end to have the pressure from the users. So that's also an interesting example that shows that actually you can run worldwide business on just a handful of machines. And that's yet another example of the ISV that is using Starcounter. The company is called Modular Management. They do configuration management systems. Imagine that you have a big factory plant and you have to assemble the aggregate, such as the paper manufacturing aggregate or any other complex aggregate that consists of many different parts. And these parts become damaged, you need to replace them, you need to buy more parts, you need to configure and update the system. And this is a complex computational task. They have models that they need to build on their computers to afterwards build the actual physical device. So it's a good example of a highly computational intense application that is combined with high transactional and high analytical load. And they previously built their system on Java plus Oracle, and then they had to replace Oracle with their customly made in-memory cache. But they finally turned into using Starcounter because they realized the potential. And they actually evaluated several technologies on the market to move away from Java and Oracle. They evaluated SAP HANA too, but in the end they decided to move to Starcounter. So currently they have rebuilt their system in Starcounter using .NET, using C#. And for some operations that previously took 30 minutes to calculate in their previous architecture, they now managed to fit into seconds in Starcounter. So it's definitely a game changer for them as the ISV. They can gain new markets and increase the revenues. And at the evaluation of the technology, they actually looked at many factors, not only the database performance, not only transactions per second, but they looked at the way how conveniently it is for you to model your schema, and how easy it is to project the schema to your objects in your code, in your business logic. How easy it is to build full stack solution on the platform. How fast it is the round trip between the client and the server. All these factors they took into account. And Starcounter is the application platform. So when you talk Starcounter, you really consider the full stack loop. From the very back end in the database, in every change in the data in the database, to the very front end, to the user screen, to what the user sees on the screen. That's sort of the multi-factor chain, and each step in this chain is important. And Starcounter takes that into account. The last example of the ISV I want to give you is a company called Mopedo. They do automated ad auctions in a somewhat new fashion. So the problem is that the advertiser usually wants to take data in their private clouds. They don't want to share this data in some big cloud to share it with the customers. They actually want to take the data privately, even though they want to continue bidding. And that's the system they built. It's essentially a distributed system, and they turned to Starcounter for low latency. First of all, they really had to do milliseconds operations, and they could only achieve this with Starcounter. This company currently is run by one developer, but he manages to do everything for the company. So all these examples that I showed you are examples of a single machine deployment, which are very powerful and that allow the enterprises to serve large amount of operations on a daily basis. And the complexity of the software they build in terms of lines of code, in terms of the layers of the system, is really smaller compared to what you can typically build using conventional stacks. For instance, conventional stack is when you take SQL Server, you couple it with entity framework, then you take Nginx and you plug it all together, choose some front-end library, and you have such a setup that can be actually vastly simplified if you turn into in-memory application platform. So I want to explain why is that possible for those companies to build such kind of setups. So the idea behind Starcounter is that in a typical software architecture, you have a lot of layers that need to interchange data. You have client side that needs to talk to the application needs to talk to the database, and the database, if it's a disk-based database, it needs to talk to the disk, back and forth, back and forth. That's sort of the problem. And in 2000s, it was quite easy to develop some system that didn't really perform well, then you just add more CPU power, and it starts to fly. That's how you manage to build good enough systems using just some Python code or Ruby on Rails, and it was okay. But currently the problem is that you cannot add more CPU power to these setups. There is no free lunch. You really need to turn into the technology that is more capable than just adding more CPU power. You can add more CPU power, add more cores, but it will not fly faster for many reasons. So in the end of the 2000s, the in-memory databases came to be, it became obvious that you can actually use the main memory as the primary store, and you can use disk as a secondary store. So currently, in-memory database today is not something new. It's not surprising. What's more interesting that with 3x point memory, it actually becomes possible to completely get rid of disk. You don't need to store the operations in the log anymore. You can actually store everything, your current data, in NVMe chip, and you can read and write, and it will be persistent, so that when the machine goes up, you actually get this data instantly to memory. So that was the case on the market. Nevertheless, in a typical enterprise system, you can replace slow disk-based database with faster in-memory database. The things do not go as fast as expected. And this has been seen in many cases. We know customers that took SQL Server, classical one, and replaced it with in-memory option SQL Server and tried to make things faster, but they really couldn't do that. So it's kind of suboptimal just to replace the database and keep the rest of the stack intact. So the next step that we realized is to remove this communication between the application and the database. And that was our question. Why do you need to take the data from the database on every single request and bring it to the application? Data is changing frequently. Application is not changing that frequently. So why not bring in the application to the database instead? Why not actually eliminating this data movement? And that's what we have done. And I mean, you heard what Gekås is doing, and today we see the rise of the companies that are doing similar approach. You bring the computation to where data lives. In contrast to store procedures, where you take your pieces of code and you put them inside the database process, like SQL Server does today. In SQL Server 2017, you can take Python code and you can put it in the database. SQL Server compiles it for you and executes inside the process elements. In Starcounter, we do the opposite. Actually, what we do is we take the application heap and we replace the application heap with software transactional memory that runs with the database. So it's like software transactional memory that is brought to the application server with persistence, which is effectively a database. Starcounter is fully asset compliant. You can do arbitrary, complex asset transactions. And let me just give you an example of how this looks from the coding perspective. So you want to create an application in Starcounter. And you say that we have a class person. I'm not doing C# exactly, I'm doing it schematically, never mind. Yeah, I'm a C++ guy, so so you have a class person, and the person has first name and last name, and you want to store these persons in the database, and you want to do transactions on them. And in a typical .NET application, the way you do is usually you say that you have an object of person, and then you say that the person's first name goes to John, something like that, right? So now I'm going to make Starcounter application out of this small piece of code. To make a Starcounter application, first of all, you have to say that some of those classes now become persistent classes. So what I've done here is I actually marked this class to become a database class. You heard a lot of this terminology from Java guys. It's off-heap versus on-heap. Starcounter is neither off-heap nor on-heap. Actually, we replaced the application heap with Starcounter heap. So for you, as an application developer, the way you program feels like you're doing this on-heap. Nevertheless, it's not in managed heap anymore. It's actually replaced with Starcounter now. Okay, so I add this as being database class. Then I want to do a transaction scope. So what I'm doing here, I say that now I want to do a transaction on top of this scope. And this becomes a transaction. So what happens there is that I create an object, I assign a value to this object, and then this object has been written, stored in the database. And if there is a conflict, the transaction is going to be retried. When the transaction is running, it sees the snapshot. So this is an optimistic currency control mechanism, snapshot isolation. And in this mechanism, the conflict resolution happens to be in the end of transaction. And this is a typical pattern in Starcounter. You create database objects and you wrap them in transaction scopes. That's basically it. So here, after you write the code and you want to run this in Starcounter, first of all, you compile the application. Then we take the idle code and we analyze the idle code with technology like PostSharp or Austin Analyzer. And we figure out what happens with the database objects. And we substitute the calls that .NET adds for on-heap operations to calls to Starcounter database. And then after this process has been done, we run the application. And now the application is still a separate process, but it runs on top of Starcounter. So that's how we do it. That's the core of our technology that we call virtual machine database management system. That's why it's virtual machine, because we virtualize the memory in the application. Okay, you might run several apps in a similar fashion, and all the apps oversee shared data objects. So you have effectively a shared memory mechanism that allows applications to interact with each other on shared objects. And these are not stored procedures. So actually, this code is .NET, it's vanilla.NET, and you can do whatever you want. You can use third-party libraries, it's up to you. We don't want to let you learn new languages or store procedures and doing this old way. We actually want you to stay in your zone of comfort with your language. Currently, Starcounter supports .NET and it runs on Windows. This is historical. However, we have version for Linux that we're going to release on the next month. And we are working on versions for other languages. We work on version for Node.js and Python. And as you see, supporting new language, it's not just adding another API to this language. Actually, it's more than that. You have to analyze the source code or idle code of the compiled entity, and it's very different from platform to platform. In .NET, it is one way. In JVM, it's a completely different way. It's kind of complex. So let's move forward, and it's not only about the backend and application and database, it's also about how you talk to the client. The problem here is that you want to minify the channel utilization by the protocol. You don't want to send massive amounts of JSON or HTML. You actually want to optimize of rendering for the state. And the other problem, which is interesting here, is the dependency tracking. In a typical application, what you usually have is you want to notify the user on the screen about the changes happening in the data. For instance, some application changes the quantity in stock, and you need to propagate the change of this quantity to the user screen while it operates on the data. And what you want to avoid is you want to avoid manually programming this view maintenance problem. And that's exactly what we do. So in Starcounter, the database backend has a push notification as the first-class citizen. If you want to oversee the changes in certain data or certain views, you can easily do that. You just subscribe to that, and then you can do whatever changes you need. Moreover, we actually calculate the difference of the view for the clients automatically. For instance, you might have an interface state on the server side, and then you have the mirror of the state on the client side. This is MAB and pattern. How many of you heard about MAB and pattern? So a couple. So you have the pattern in where you have the user screen state as a tree. It's usually represented in JSON. It's a tree, and this tree represents the user control elements. You have text field, you have buttons, and all that. And then you can have this state controlled on the server side. On the server side, you have this tree. You can observe changes on the elements of this tree. And then you have the mirror of this view model tree on the client side. And the client side is being rendered by the client-side framework. And in that scenario, when you change something here, the change should be reflected in here, and vice versa. And if it's changed, then the backend application logic can react to these changes. So in Starcounter, we do it this way. We actually calculate the patch between the application server and the client state of the view model. And we only send the patch over the network. And this works similar to shared editing of documents in like Google Docs, when you have several users editing the same document simultaneously. So by this, we actually eliminate yet another bottleneck, yet another complexity level in the typical application. You don't want to program these things yourself. You want to rely on the platform. Even though in some cases you actually want to change things, it's possible. In Starcounter, there is no problem of building classical backend only applications, microservices with REST APIs. You can do all that, and the result will be high performant and easy to develop. Nevertheless, we believe that it's important to provide for full stack application development in a way that is convenient and rapid. And I think that's one of the differences between us and other in-memory vendors, because we actually address full stack. And this full stack has a lot to do with removing these redundancies between the layers. Not only backend, full stack is important. So what I just referred to is what's known as the spreadsheet-style programming. In spreadsheet, in Excel, you do not program propagation of the changes across the cells. You just write the formula in a declarative fashion, and the engine that calculates the spreadsheet does the rest for you. And Starcounter is essentially doing the same. You might imagine, for instance, you have a table on the screen where you have the quantity in the stock, you have the price, and you have the total. So when the quantity has been changed, you need to change the total. And the total, this total is represented like a select sum query in one of the fields in your view model. So when the quantity changes, Starcounter will automatically identify that and will propagate this change across your logic and your query. And you need to do nothing in your code, 0 code lines to do that. And that's kind of efficient. We see that the number of lines of code is reducing dramatically for our users. So that is what we call collapsing the stack effectively, because we eliminate the need for all these layers as being separate entities, and we allow you to focus on this, on the application code. And the rest, Starcounter takes on it. You don't need to care about the performance in production because it's going to be good with Starcounter. That's what we see. People create some prototype, they might spend 2-3 weeks prototyping the thing, and they already manage to run it in production and start to make revenue. So this is kind of awesome. Typically, it's not the case. Typically, you have to get an architect person and build the architecture, and it can take a lot of time for you to do so. So Starcounter power is actually in this combination of being super fast and super easy, as we say. It's simple and fast. And you know, I don't think that Sberbank will consider using Starcounter, because Sberbank is one of the largest class deployments in the world, and they definitely need the scale out in the corner today, at least. But Starcounter is not addressing the hugest enterprises. Starcounter is addressing the long tail of small and medium enterprises. And those enterprises do not have enough manpower or enough financial resources to invest into complex technologies. They want to have results fast and now, and they need to compete on the market. That's difficult. And Starcounter gives them that. And that's the difference between us and other memory vendors. We actually allow for small companies to start flat, go smooth and fast. And move forward. And the next step after you consider how you build applications in a composable way, you run several apps that share data in one database. And then you actually want to achieve such a good phenomenon that you get with microservices. When you get separation of concerns, you have different entities responsible for different kind of things. And by physical separation, you also attain the logical separation. However, the problem is that in many cases, this is not real time. If you need to interact in one user transaction, you need to orchestrate all those data flows across the servers, it becomes quite cumbersome, it becomes slow. And that's the problem. You can build awesome microservices architecture, but it will not perform. It will be slow. You can have minutes, you can have seconds latencies in such a system. That's not acceptable. So what we aim at Starcounter is to keep the same level of logical separation of the entities, which are applications, and not having the problem with physical separations of them. So in Starcounter, the data is shared between the applications. But now we start to develop applications in such a way that they don't actually know about each other. They only need to interoperate on top of some shared data model, and effectively that's it. That's exactly what you achieve with doing microservices, but now you put all these microservices on one single platform, runs on a single machine with very low latency. Please.
In microservices, what I know is that you don't share any model at all. You have your own model and you don't care about the model of the other one. So otherwise you have competition in order to evolve your microservice.
The problem is that there's always some state, especially in the business applications. You actually need to operate on the stock quantity in the accounting system and in the warehouse management system, so that you actually have a shared state. But now you have to either put it in multiple machines, multiple microservices instances, or remove the shared state from these machines and put them in the messages. Either way, it's suboptimal because now you have 2 problems, 3 problems, 4 problems. You have the same data spread across multiple machines. So actually, what you're going to see in the business applications that you need shared state. And it's very difficult to achieve the microservices architecture. In case when you have pure separation of concerns, when they don't actually depend on each other, it's okay, but it's a kind of limited case. We have seen a lot of setups when people build such an architecture, but they fail to realize that if this one is off, those will not make sense anymore, because on the user screen, the interaction happens to involve all those 4 parts. Does this answer your question?
More or less.
So this is what I'm talking about. Typically, you actually need to have that sort of orchestration somewhere on the client side or in some middleman machine that needs to take data from multiple parts that interoperate, and you need to mesh them together. And this is known as API management. You know, classical microservices approach, you version your APIs, and you need to sort of know about these APIs and interact with the systems using those. So that's not real time. Microservices have a lot of good merits, but it's not real time. And what Starcounter allows for is to move from this way into this way, where you keep the logical separation of applications, but now all this interaction happens to be in real time. And the user still sees one coherent system on the screen, but the system is comprised of multiple composable parts. And that's actually powerful because now you might imagine a company that wants to build their system out of parts from third-party vendors. They don't want to build everything from scratch. They want to take accounting system from one vendor, they want to take CRM system from another